I think it's time to move on to the second talk on this topic. And our second speaker is Adam Reilly. Adam is a physical scientist and grants project officer for the Southeast New England program at the U.S. Environmental Protection Agency in Region 1. He is interested in better understanding and communicating the impact of the environment on community health and wealth. Please welcome Adam.
Awesome. Thank you so much, Kathy, and thank you, everyone. So as Kathy said, my name is Adam Reilly. I am and today I'm going to be presenting conclusions from a recently completed R2P2 project, which was done in partnership in Region 1 and ORD Narragansett. For those not familiar, R2P2 it stands for the Regional Research Partnership Program. And I undertook this work in partnership with Nate Merrill, Kate Mulvaney, Phil Colarusso, and Erin Berman, some of whom you've heard speak previously today. So quickly, I know most of us already know this, but just as a summary about today we're going to be focusing on blue carbon. And for those who aren't familiar with the term, blue carbon it represents natural ecosystems that sequester carbon in their soils or tissue. These include salt marsh, which will be the focus of my talk today, but I also did want to give an honorable mention to mangroves and eelgrasses for those folks on the call who work on those as well. But today, like I said, we will be focusing on salt marsh restoration. And because these blue carbon ecosystems focus on carbon sequestration, they naturally are, an important piece of the puzzle when it comes to climate adaptation. Not only because they demonstrate a portion of potential future carbon sequestration, but also because they've already store a significant amounts of carbon through deposition, through just enhanced photosynthesis. They already represent a large number of carbon stores, provided that these systems remain healthy, and that's key. But for the focus of my talk today, I want to talk about what happens when salt marshes, in particular, become degraded. And what happens when they become degraded is that they end up producing greenhouse gas emissions rather than, in addition to continuing to store them. So the reason all this comes down to changes in salinity, a common and salt marsh freshening. And a common cause of salt marsh freshening typically is inadequate tidal flushing, or when salt water can't freely move within the system, often because of a narrow culvert, but a narrow culvert is a common tidal restriction, but there are others as well. But when salt water can't adequately move throughout a given salt marsh, that system ends up transitioning over to a freshwater state. And once the salinity throughout a given system transitions below a threshold value of roughly 18 parts per thousand, that's when methane can start to be produced just through natural microbial processes that become activated low saline or in a hyposaline state. So the question then, is what to do about these low saline environments, and how do we essentially turn off that methane faucet once it's been turned on? So there are typically 4 approaches, that I just would like you to think through for a moment. And just to continue with this faucet analogy, we could essentially do nothing, assuming things, continue to worsen. That would mean that more methane potentially is produced as a higher number of salt marshes become degraded. And that's not accounting for sea level rise as well. And this is only focusing on methane and not discussing a release of the stored carbon in their soils, like Dr. Trundafir mentioned previously. What could happen is that the systems continue to degrade at a current rate, which isn't not better, but it isn't, necessarily worse, and that's also probably more unlikely than things becoming worse. Or we could conserve. Just focus on from the perspective of methane abatement. This would look like working to conserve just to the point, conserve salt marshes just to the point where the tidal restrictions are abated to essentially shut off that methane pump, or we could restore, and that's kind of like the kitchen sink model, and maybe more than what we need for just focusing on methane abatement. So if we were to go for conservation, there's still a lot that we don't necessarily know about the relationship between salt marshes and methane production. So what we set out to demonstrate over the course of this project was why we should pay closer attention to this space by talking specifically about the benefits of salt marsh restoration projects. And to do that, the first question we wanted to answer was how we measure the benefits of salt marsh restoration. And we chose to think about benefits in two ways. The first was in calculating the social benefit value of avoided methane emissions. And the second was in calculating the fiscal benefit that could potentially have been possible had restoration projects been had participated in a voluntary carbon crediting program like the VERA's verified carbon standard. But in order to do either of these things, first we needed data. As fantastic as the R2P2 opportunity is, there are no research dollars attached to this opportunity, and maybe just throwing that out as a potential idea for future recipients. But because it was running, we were interested solely in data that was already collected from projects that were already completed, just to demonstrate what such a methodology might look like in the future. So first step was data collection, and the Mass Audubon actually had a fantastic salinity data set from, I think, a couple dozen sites throughout Massachusetts. These were salinity data sets that were recorded both before and after a given restoration project was completed. And from there, I was able to calculate the average pre-restoration project salinity value and post-restoration salinity value. I'll get into this in my next slide, but I was interested in projects that resulted in an increase in average salinity following a restoration project. So that limitation alone actually resulted in negating almost half of the sites that I had identified that fit my initial criteria. So of the 6 sites that met my previous criteria, only 3 of them were usable because only 3 of them resulted in salinity improvement after a restoration project was completed. The reason why I'm focusing on salinity is because of a 2017 meta-analysis that allowed us to infer methane emissions from average salinity rates. This study, Kevin Kroger et al., 2017, performed a meta-analysis that found a true mean pre-restoration emissions factor of 41.6 grams of carbon equivalents per year. Or a geometric mean of 19.4. So this in and of itself is already provides a range of values that are going to come out of this estimation. And I'm sorry, this should be grams of carbon equivalent. So this was the pre-restoration value, and then the post-restoration value. So once the restoration was completed, it was to be assumed that the result was a value of 0.46 grams per square meter per year. So this is a simple multiplier that's dependent on range. And the criteria here is that if it's pre-restoration, if salinity values are below 18 parts per thousand, and then provided that salinity values are above 18 parts per thousand, so they improved, then you can apply this smaller value and then what's shown here in this equation is that we're taking the difference of the two to get avoided methane emissions. And I want to fast forward a little bit, but it basically, from that, we were able to identify the total annual avoided methane emissions in tons across the 3 sites. And then from there, we did a similar analysis. Once we were able to get our values in estimated annual avoided methane emissions, we were then able to apply the EPA's 2021 social cost of methane to estimate the basically the avoided costs or the avoided damages, which we treated as a net benefit resulting from the restoration of each of these 3 sites. A quick note on discount rate. We value future decisions and effects differently than those of present day. So we use discount rates to take account for this variance in our decision making. We care more about things that happen to us, tomorrow than we do necessarily that we think care about things that will happen to us, at some point in the future. So the way that we evaluate that variance in decision making is through the use of discount rates. So the higher the discount rate, the higher the assumed value, present day value compared against future damages. So we used a range of discount rates to infer the social benefit of avoided methane emissions. We used 2.5, 3%, and 5% to demonstrate the range. And this is what that looks like just using the 5% average. So the EPA, that technical document allows you to calculate the year average from 2020 to 2050. And then this is for one site, and then we summed up the value by 2050. The reason why we started in 2020, even though these restoration projects were completed in the early 90s, is that we had to assume that the benefits from these completed restoration projects were seen, into the future as well. And then this is just summarizing the impacts using a 3% discount rate, but also assuming different emissions factors of 19.4 and 41.6 that were demonstrated by Kroger et al. So what we're showing by 2050 across these 3 sites, which were approximately 22.7 hectares, was a social benefit value of between 300 and 650,000 in avoided damage costs by 2050 across the 3 sites. So, all right, those aren't real dollars though. Those are just assumed benefits inferred by calculating avoided cost. So the next step of this project was to ask ourselves what the real dollar benefits could look like had these projects participated in a voluntary offset crediting market. Really quickly, just how blue carbon crediting works. Say you have a degraded site that you put work into restoring or conserving. You then monitor that site over time to demonstrate that your projects demonstrated a specific benefit. Those benefits then are translated into carbon credits that you can then use to offset the cost of your restoration project, or that you can bank. So that's generally how carbon crediting works. I'm going to fast forward a little bit here. We used Vera's blue carbon crediting approach to calculate what those avoided methane emissions would have looked like across the 3 sites had they happened today. And then we also applied both emissions factors of 19.4 and 41.6 to demonstrate a range. And what we found was a range of roughly 28,000 to 60,000 in credits, in blue carbon crediting that could have been available had those projects participated in a voluntary crediting approach. So what does this all mean? There was a 2017 data set, McGarrigle et al., that identified all marshes throughout Massachusetts, but more importantly, also identified their relative condition. From that data set, I was able to infer that there were 475 salt marshes with tidal restrictions, so approximately 932 hectares. Applying the same approach and assuming that all tidal restrictions could be removed and salinity salinity values improved, we're looking at a total avoidance of about 380 tons of methane a year, or over $200,000 a year in carbon credits. So by 2050, with that higher emissions factor, we're looking at 11,500 tons of methane avoided, over $6 million in credits obtained, and a social benefit value ranging from between 17 and 35 million. Again, assuming that all of those would be successful. So that's like the very upper bound, understanding that it's probably much less than that. But again, I'm wrapping up now. There's a ton of takeaways and caveats that had to be included within that, and all of them come down to the quality of the monitoring data that are included into this approach. Critically, the approach that we took, to our understanding, would have been a valid approach through, and one that would count towards Vera's Blue Carbon initiative. But the data that we used to support our analysis, were those that actually were collected by, sixth graders over decades. And while, that's not, meant to discount the contribution of those sixth graders to this field, it does, really critically highlight both the need for better data and the ease with which it can be collected. And monitoring is key. Monitoring, validation, and verification of these restoration projects is key, especially when so many companies are interested in such an approach, in offsetting their emissions through participation in a voluntary carbon market. And we're also beginning to see what that looks like when these offset programs overcredit and get these wrong. So blue carbon crediting is new. It's fairly new. It's catching on, but there's still is a lot of need for us to tweak the verification validation approach that we take, with this methodology. So just in summary, we know.
So findings. Adam, I think we have to move on to the interactive session.
Okay.
To give everyone a chance to ask questions of both speakers.
Sure. So I'll just this is my last slide.
Okay, great.
Yeah, so sorry about going over time, but just in summary, so we know that there's a lot of opportunity here, especially with the increase in BIL funding, especially which would include culvert widening to address methane abatement, and to providing a methodology to allow states to track and monitor the impacts of these infrastructural approaches, is critical, and also identifies a further need to address salt marsh restoration and more closely meet their greenhouse emissions reductions targets. But we don't know how to monitor them cost effectively yet, and we also don't know the distributional extent of these greenhouse emissions, which is what we're hoping to identify as a next step. I'll close out there.
Thank you, Adam. Gee, that's so fascinating. But both of your presentations, first on the economic valuation of marshes, and then the voluntary offset markets. Thank you both very much. And now we get to ask you some questions. Please put your questions in the chat, put a Q, and then the name of the speaker, if you have a specific speaker who you want to ask a question of. And also if you have a comment or some feedback, put a C. And we'll turn it over now to Joan to see if there are any questions in the chat.
Everyone's been very efficient in their questions and getting responses. So the only one that came up during Simona's presentation was a question by Caitlin asking which data set did Simona use as the basis for her initial salt salt marsh acreage in the SLAM model. And Simona responded the 2010 data from the, I guess it's the National Wetlands Inventory. And that was it, unless Caitlin or Simona, you have any other follow-up questions on that topic?
Okay. Well, let's keep those questions coming in, and meanwhile ask if the speakers have anything they want to ask of one another or comment on one of those presentations while we're waiting for additional questions to come in.
No, I just have a comment. I think Adam's title was so creative I think it was Fantastic Wetlands, right? I wish I titled mine just to up you, Adam, to Unbelievable Salt Marshes and Why We Must Absolutely Value Them. But it's too late for that now.
Thank you. I'll comment on your presentation. It's so critical to think about how these systems react, to sea level rise projections, which we have absolutely signed up for at least a portion of sea level rise in the future, and my analysis didn't cover that at all, and I'm curious now to see what that would look like, how to be incorporated like a sea level rise model. So maybe in the future.
And here's another question that was just posted in the chat from Maryland. How effective has the economic modeling been to convince government and businesses to support or pay for restoration?
I can say on my end, my experience and my understanding is that states are just starting to realize the benefits of salt marsh restoration, and they're really hungry. They're really interested in learning more about salt marsh restoration benefits. In my conversations, it seems like states have a better understanding of the costs associated with salt marsh restoration and not as much about the benefits. So that was really one of the goals of my analysis, was to figure out how best to kind of begin to quantify the benefits, and then to use that as a way for states to to encourage states to prioritize these going forward.
On my end, I have nothing to report since this is a brand new study, and I'm not aware of any studies that quantify the economic value of marshes in Narragansett Bay. So we're looking forward in seeing how effective this has been in convincing these businesses to support restoration.
Okay. Looks like there's nothing else in the chat. So I think we are ready to move on, and thank you so much for these great presentations. Appreciate it, both of you.